I'd like to welcome everyone to this, was it semi-monthly, bi-monthly? I always forget which is which. Mathlib community meeting. I'm sure some more people will filter in as we get a little bit further into the meeting. But thank you for joining us, those who have made it so far. So I was thinking about what would be a good theme for this meeting, and at least here it's April and the sun has come out and all the trees have shunted out their yellow dust upon all things, man, machine, and otherwise. So, it'd be nice to have a good spring cleaning. And I think for Mathlib, a spring cleaning would also be, in a lot of ways, a very useful exercise. So, in the spirit of that idea, first let me open it up and see if anyone has any specific topics, issues, things that have been simmering for a long time that would really fall under this umbrella of spring cleaning. Well, in that case, let me get it started. So recently, we've unbundled the order hierarchy from the algebra hierarchy. And much thanks to Kevin for some heroic reviewing to get us there. Now, we just have to do one other hierarchy separation, right? Should we be unbundling analysis from algebra? And if so, what would that look like?
Is this normed modules?
I mean, there's a discussion right now about refactoring norm modules, but it's not unbundling. It's just sort of pushing the pieces around. But yes, right now, norm module is something that extends module and something else. I just looked at it a moment ago and forgotten already.
Yeah, I don't know what analysis is. Is it a norm?
Let me look it up. Okay. Well, let's see. We have normed space. So is normed module new in that? Yeah.
Oh, is that not a thing?
No, I think that's maybe a new thing. We have norm space, which is somewhat unbundled. It extends module.
Oh, we have normed
include...
ring. What about there's normed ring then? That's definitely
Okay.
algebra and norms.
Normed ring.
Sorry, that's yeah. Does that count?
Oh yeah, that certainly counts, right?
Okay, great.
So the normed ring extends norm, ring, metric space.
Yeah, I'm already like, what the heck are we doing with a norm and a metric space? I'm already completely confused. Oh, I see. Yeah, I do see. You need the ring to get from the norm to the metric space because you define the distance from A to B to be the norm of B minus A, which hard luck. So, yeah, so unbundling them might be more difficult, right?
Well, I mean, you could try and separate the ring from the not ring stuff. and just try and write mixing classes for the
Right. It could
invariants
be
you expect to hold.
is normed ring.
Hmm.
So this was. Have you been following the local fields discussion? This is
Only in the sense that I have to go on to Zulip every time and click all the messages to make myself feel like I'm keeping up with
so
the daily 200 to 300 messages I see.
so a local field is Filippo wants it to be a ring, or in fact a field, and then evaluation,
Okay.
which is a function going from alpha not to the non-negative reals, but to some arbitrary, totally ordered monoid with 0. And then a p-adic field is that plus some predicates on top.
Mm-hmm.
And I'm thinking that we should maybe be unbundling this. So then that would be a field, but then you have this, the analysis, or whatever you want to call it, is some valuation taking values in a different type. And so I would like to. We're about to embark on this, and I would like to make it unbundled, because we've got this 8% speed up in time class inference. Now we've unbundled, algebra from order theory, and I was a little bit confused about what that would look like, because it's not like normed ring. It's just everything's on alpha, and so it looks sort of feasible. But with valued ring, one issue is that valued k gamma depends on the fact, gamma has some algebra and k has to have some algebra for valued k gamma to make sense.
Mm-hmm.
So I'm a bit confused about how to unbundle that, but this is sort of very pertinent, because we're going for local fields right now, and we've got 3 different teams of people working on local fields, and I'm slightly scared they're going to end up using 3 different definitions, and there's going to be chaos. So we somehow need some design decision right now, but it's much less clear than this old normed or this algebra and order stuff, because the quotes analysis, or whatever you want to call it, somehow depends on the algebra. This valued k gamma type needs the fact that k is a ring, so it can't be completely extricated. So this is something I'm just a bit confused about at the minute.
Well, I mean, the speed up was, I think, completely due to the fact that you got rid of these instances that jumped you from one hierarchy to another.
Yes.
So you didn't end up.
So that's the rule of thumb. Are we creating instances that jump from one hierarchy to another?
And if you, so there's 2 things that could happen, right? At the most basic level. Either the instance search succeeds or it fails, right? And the way it's constructed is, if it fails, it fails through no fault of its own, trying every last possible.
So you can say that, but why is it looking for topology at all? The entire question never mentions topology. It's like, let's try and prove this is a ring by proving it's a topological ring. No, don't do that. It's like there's no topology anywhere. It's like, there's something wrong with the system.
Right. And so
so
if it succeeds, right, you can mess around with priorities to make sure that, the one I really want is going to be at the top of the list when it goes looking for it, generally. But if it fails, it's going to go through there at some point and try and, that's, try and figure out if it's, some E infinity ring spectrum, when I just want to know I can add 2 things. Right. So there's those 2 issues. Now, along these lines, there has long been, and this is another, I think, a good topic for spring cleaning. There's been, a lot of noise talking about writing down some type of cut rules for for type class search, which basically says you only try these things and you don't ever try these other things. Right.
What are we talking about? Are we talking about in core? I don't know anything about.
Yeah. I don't know if we're allowed to talk about such things in the Mathlib community meeting, but at least providing an RFC with, some desired behavior for what we would expect from this. Oh, there goes my camera.
Yeah, I mean, somehow the way it's worked with the ordered ring stuff is that lean 3 changed to lean 4, and they were just like, okay, now type class inference works like this. And it's kind of taken us 2 years to bite the bullet and say, okay, that means we need to fundamentally redesign our principles, redesign the definition of ordered ring. But we've done it yesterday. It got merged yesterday. This is why I'm so excited. I merged it. So, you know, I kind of think that maybe it's just going to work like that in the future as well. Like, you know, the lean core people make their decisions based not just on Mathlib, but, you know, on a number of criteria, and then we're sufficiently flexible that we just adapt to what core lean says. And I'm kind of happy with that, because core lean is making decisions, you know, based on information that I don't have and I don't really understand.
Yeah, and I also think, you know, I would tend to defer to their expertise in a lot of these areas, unless you really have a, you know, hard mathematical objection to something.
No, Leo was right about flat structures, right? Yeah, lean 3 was sort of the old structure command, because old structure command was just the best. And Mario was like, it shouldn't be called old structure command. And then it became old structure in the sense that it disappeared and we could only have new structures. And so like Leo was just like, screw you. But somehow he was right, because at the end of it, you know, at the end of lean 3, we were running into kind of crazy timeouts. And it was just like, why the heck doesn't this work? You know, it doesn't work because of what Leo could foresee 3 years previously, just when he was telling us to stop using old structure command, and we were just ignoring him. So I sort of trust that the system is designed well enough, and we just have to, yeah, as you say, spring clean. We have to spring clean our type class system, but I've no doubt that it can be done. I've no doubt that it can be done. It's just, I don't know, it's hard work. But you know, we're making it. We're making it happen. Yeah. So, do you want to embark on normed rings? Is that going to make things super fast?
I don't know if it'll make things super fast, but
well, we just say 20% type class inference is now 20% quicker in Mathlib as of yesterday. I mean, that's a big number.
Oh, well, yeah. I yes, and I did sort of a hacky attempt at unbundling this before, but what I did sacrificed a lot of the benefits, because simp would end up trying tons of things that just did not work anymore.
Oh, interesting.
Yeah.
So there's an art to this, is there?
Well, I don't know if I'd call it art, but there's trade-offs, right?
Yeah.
But I mean, I think, you know, certainly normed ring is a good candidate for this similar type of treatment here.
Yeah. Well, what about valued ring? That's what I'm confused about. Well, it doesn't exist. But yeah, valued.
Let's see. Oh, just valued the wrapper.
Yeah, valued. Yeah.
I don't know. I'm sort of skeptical about this being a class.
Valued?
Because yeah, I mean, so, you know, it's convenient, right? Why do we make things classes? They're convenient. But
I mean, it's just like having a norm. It's just that the norm isn't real valued. It's just valued in some abstract thing that looks a bit like the non-negative reals.
And are we saying that there's always a canonical choice for anything? You know, you pick your favorite type. It's a ring. There's always going to be an obvious choice for this. I think for certain, you know, familiar types, yeah, but
no, it's for a finite extension of the p-adic numbers, there's at least 2 canonical norms. But I mean, that's also true for norm. There's but for the complex numbers, I mean, you know about for finite extensions of the p-adic numbers, the question is, do you want the norm to extend the usual norm on the p-adic numbers, or do you want it to be off by a factor? That's the thing. Do you want, and there's no good answer to that. Do you want to divide by the degree of the extension or not? That's the issue. Like one way of taking the norm of a complex number is take the algebraic norm down to the real numbers, z bar, and then take the norm of that. So then the norm of x plus iy is x squared plus y squared. So the square of the usual one.
Right.
And Tate argues that that's a very natural norm on the complex numbers because it measures how additive Haar measure gets scaled. So even for familiar objects, there's more than one norm you want. Yeah, I don't know. So you're saying it shouldn't be a class? Oh, that's interesting.
Well, I mean, that's sort of for me, a troubling signal that you make something a class, and even in a simple example like that, you have some questions about which is the right choice.
Yeah, come from Lean 3 apparently.
Well, I understand the motivation.
Mathlib 3.
It's very convenient if Lean just figures out this, all the data for you without having to manually fill stuff in. But that has to be managed appropriately. Otherwise, as you saw, things become difficult to, actually edit and build on a daily basis.
Yeah, it's from the. I think it's come from the Perfectoid project originally. This concept, but I don't know. I don't know whether we decided it should be a class or not.
Does anyone else have any kind of spring cleaning thoughts along this line? Or somewhat orthogonal to this?
I guess I'll say how much I'm a fan of this unbundling, even though I don't interact with anything algebraic that much, even just like incidental interactions with order API, and it's made my life easier.
Can you identify like a concrete representative of your life becoming easier?
There's been this PR review thread about I'd like to be able to take a T-sum, a topological sum of ENATs, and there's ENAT and ENN real are both. I think they're the only natural examples of types where sums always converge. So there's a topological abstraction, which is, I think it's basically a complete lattice with a canonical ordering, and a monoid structure. And I think it was difficult to express that combination of ordering and monoid structure using the old type class system, but now it's trivial.
Oh, so the unbundling has solved that problem, has it?
It's improved things. I think it might not have been impossible, but it definitely makes. I mean, when you just want a combination of this funny thing and that funny thing, it just makes it easy.
That's good to know.
Yeah, I don't know of any other targets beyond what's been mentioned where you would think of unbundling as making a huge difference in performance and experience for the user. But maybe other people have some in mind. And so for people who joined us a little bit late, the theme so far has just been spring cleaning. So spring cleaning in Mathlib a little more broadly. What are some things that kind of been sitting around for a while that you really want to take care of, and what possible benefits do you think could emerge from actually tackling those issues?
Oh wow, I've chased back the definition of valued, and originally it was a class, but gamma z, the value group, was bundled. It was a class that only ate a ring R, and gamma was a field.
Mm.
Even more dubious decision, in my opinion. But then again, we didn't really know what we were doing in 2019. So I'm now terrified to look at the Perfectoid space project and discover that it was me that made that definition.
I mean, we all learn. That's what we're here to do, right?
Yeah.
It's not like people have been formalizing perfectoid spaces for decades and decades and decades.
We need to employ people to do our spring. One thing that needs spring cleaning is the 1,400 open PRs.
Yeah.
Hey, what do you think about trio? You know that core lean has priorities. Like you can make an RFC or something, and then somebody slaps P low on it, and then you kind of know that that's just code for like come back next year. I think we could do that in Mathlib.
I mean, certainly, I think we could do that. It'd be good to have a discussion about the benefits, right? I don't think you want to.
I think it would just cause a huge
discourage
argument.
People, right? But on the other hand, I think we're very, very cognizant of the fact that it's great to have a lot of energy from the community, and we want to try and harness that energy as much as we can to move things forward. And we probably have overextended ourselves a bit in this way. Right? And so trying to strike a nice balance between, encouragement and support, but also, judiciously allocating resources to make sure that people aren't overwhelmed, people aren't feeling frustrated. Everyone kind of knows what the state of play is, and
it's a very
less centralized version of the priority labels. Should we encourage people to vote on issues like the Lean Core repository does?
You mean put little?
Yeah, just say put a thumbs
up
up reaction if this would be useful to you.
A thumbs up if you're too lazy to review this PR but want it in anyway.
Exactly. Or maybe you don't know enough Lean to review it, but someone's told you that you'll need this to do what you want to do. And I mean, suddenly they don't have to be binding and say maintainers have to do this first, but having some vague idea of actually this one's blocking 10 people and no one cares about this one that you're looking at right now is kind of a way to focus the effort where it has more impact without explicitly prioritizing things.
I forget what it was. but there was some issue on the Lean 4 website that got like 15 thumbs up, which was like far more than any other thumbs up before. And then Leo explicitly said in one of the meetings that like 15 is not a very big number. So, and I kind of thought, well, then the entire thing's futile. It means you'll never get a big number. But I mean, I do see people saying, oh, I've done some cool algebra, and I think, oh, I'd like that algebra in, but I'm not entirely sure I've got any space to review it for the next few days. It's got about 10 p.m. last night. I was reading the Lean chat, and there was just some person I'd never seen before saying, oh, I proved Tanarchian duality for representations of finite groups. And I opened a PR. I opened 3 PRs, and one of them is one lemma. And it's just like, and I looked at the PR, and it's just like been there for 3 weeks. And no one's reviewed it. And it's like, it's a perfectly good lemma, but it's a new contributor. I'm like, what the heck are we doing? So I just like merged it. And then I read the second one, and I thought, oh, I've got comments here. So then I made lots of comments, like I golfed the code and kind of taught them about classical, and thought, great, I'm actually doing my job here as a maintainer. But that was like, you know, I just don't even notice it. That had been sitting there for 3 weeks. It's even if people are thumbsing up it, I'm not going to notice. It's not going to sort of be on my radar because it's just one of 1,400 PRs. You know, I just don't quite know how to find my way around everything at the minute.
I think at a more personal scale, I'm sure we've all been on a virtual meeting with someone who has their that screen shared, and they have, maybe it's Mac or something, number of notifications in their email box. And the number you see, you can hardly comprehend, right, how that could be. Generally, how does someone dig themselves out?
Oh, I can do that. I have 400 unread emails sometimes, but today I'm
talking
0.
about like 20,000 or more.
Yeah, then that's difficult.
Right. So whatever new system we adopt, it's not going to save us from the backlog we already have.
Mm.
But I mean, I think, you know, it's not, I don't know all the, you know, benefits and possible detriments of a, you know, a priority assigning system, especially with voting, but it's certainly interesting information that'd be useful to have when trying to direct resources to move things forward. And you can kind of get it perhaps from Zulip to an extent, but with Zulip, you know, if one person is very excited and vocal about something, it can often seem like many people are very excited and vocal about something, because the vast majority of people sitting around aren't, you know, they see no need to engage. It just, there's nothing in there for them.
With the PRs you were talking about, Kevin, the 3 new contributor ones, did they have a PR review thread?
No, I guess maybe that was what. No, not originally. Like, do you make a PR? Sometimes you do this, don't you? It's make a PR, not always. Make a PR and then just make it thread. So,
I do that every time. I mean,
oh, you do now?
I guess that a couple of years ago, Heather told me to do it.
Yeah, it's an interesting idea.
Yeah, and it's worked well for me. I mean,
yeah, but a new contributor might not know that trick.
I think it says in the instructions somewhere for making your first PR something about making a thread, but I don't know.
Oh, it definitely does, because I asked Patrika where it was, and he pointed me to this. Although when I read it, I kind of read it with the following information implicit: if you have a problem, or if you have questions, do these things.
Ah. Yeah, I
But,
made a
you know,
PR to fix a doc string. I didn't make a thread for that. Whenever I see a doc string, I kind of don't understand it. I absolutely always, the doc string just assumes I'm familiar with something that I'm not familiar with. It's like, damn it, that doc string didn't need to do. You don't lose anything by just writing information again in a doc string, do you? So, yeah, but I think there's module dot fin rank or something, which is like the rank of a module is a natural number. It's like, what the yeah, but what's the rank of a module? I just like that's why I'm reading. That's why I'm reading the doc string. Oh, I don't know what the rank of a module is. I know what the rank of a finite free module is. But I don't know what the rank of a random module is. So yeah, you fix up doc strings, and then I don't make a fuss about it. And then they just can sit for days and days and days. And then eventually somebody notices them, they merge them, and it's like great. But there, you're in no hurry. Oh, well, maybe I should make a doc string for my refactoring of Adele's. Okay. Yeah, I've got something that's been sitting for weeks. All problems dealt with, just sitting there. I'm dreading it merged. when it gets merged, it'll break Fermat's last theorem. So I'm dreading it being merged. I'm quite happy for it not to be merged while I try and fix stuff on my branch. But like the moment it's merged, then you can't bump master.
It's really felt like since the awaiting review tag disappeared that if you just make a PR and you don't do anything more, then it's just going to disappear into the ether.
Well, eventually, after it's been there like 2 months, then it gets picked up at the triage meeting. Yeah. Yeah, it's okay. We'll fix it. Yeah, we'll find a way.
I don't know how many pull requests fall into this category, but like maybe it's worth having a good for new reviewers kind of label, because Kevin, your kind of PR is I don't know what a rank of a module is either, but if I'm a new reviewer, I could probably review your PR, because if I don't know what it is and then I read your doc string and now I do know what it is, then probably your PR is good. So maybe flagging some of the PRs as good for naive reviewer is an idea.
Reviewers, yeah. No, it got merged yesterday.
Fall in that category. I feel like doc strings, you actually want someone who is deep in the mathematical area and knows exactly what the right way to teach these things is to check the doc string. And so like if Kevin writes a doc string for module rank and someone reads it having no idea what the rank of the module is, then they might believe that the doc string looks roughly correct, but actually the terminology that it's taught in lectures might be entirely different. And so you kind of want that insight of an expert for that type of thing.
But in fact, what I did was module.finrank was defined as some cardinal dot to nat of module.rank, and so I just copied the definition out of module.rank. Module.rank, it was in the doc string. It's just module.finrank, it wasn't. But anyway, yeah, so that'd be nice to do spring cleaning on that list of PRs.
What Eric said also touches on something else that's also been brought up recently, but is again a common occurrence, which is if I'm a mathematician looking at Mathlib, my experience not necessarily with writing down code, I have certain expectations of what mathematical ideas should be implemented as when I write a paper. And improving that discoverability, or we don't want people coming and saying your definition of XYZ is wrong. We want people being able to see how their definition, in most cases, follows from Mathlib's in a process they could trace through. How do we make those kinds of ideas more discoverable to people wandering in off the street?
It's a module doc strings, but we did pretty good at module doc strings. In fact, that was part of I reviewed a PR recently, and I spent half my review time moaning about the module doc string. It's like you're just assuming that the author's already a lead expert, that people are going to come along and, you know, it's these bloody valued fields again, these non-Archimedean rings. We can't. I think the module doctrine should be readable by mathematicians. That's always been my gut feeling.
That seems like we could find a lot of reviewers to do that then, right? Because if your only qualification is I'm a mathematician who knows this mathematical material, all I have to do is read the doc string. Does it make sense to me? You know, we could find a lot more people who are able to step into the plate and, you know, start swinging for that, as opposed to, is this the right implementation for what we want to prove later on?
Well, that's sort of a question the mathematician can answer, right?
Mm-hmm.
Related
I
to
don't know,
doctrine, maybe during review, we should encourage reviewers to ask the author to add things to the module doc more often. Like, it's pretty common that someone will add a whole new section to a file and not actually explain anything in the module doc string. And like, sometimes maybe they've just forgotten. Usually the reviewer doesn't notice. Sometimes the excuse is, well, I didn't add anything to the module doc string because this file already has 1,000 lines and none of them are in the module doc string. So why are the 200 I added special?
well, I'm sure it's easier. I mean, of course we could try and not count docs to the length of a file, right?
Oh, I wasn't even considering the line length limit pushing us over.
I mean, yes, there's the human line length limit where I have to control F 20, 40, whatever times to get to the bottom of the file. But then there's also the, you know, automated line length limit, which will complain when I've made a file bigger and I have to do some other stuff.
The case I'm thinking of is, let's say you have some development of tensor products and there's no module doctrine for tensor products. And then someone comes along and adds a whole bunch of isomorphisms for tensor products. And they decide they're not going to add them to the module doctrine because there's nothing in the module doctrine that even says what a tensor product is yet. So they don't have anything to reference for the rest of this. And so maybe there's some technical debt to build down of module doctrine that are just one sentence.
I mean, would it be crazy if we're testing out, you know, downstream Mathlib as a service to build something that takes a lot of these familiar mathematical notions and you know, talks a bit more about them in the documentation and then actually shows how to derive them from Mathlib itself? Mathlib examples.
Someone has to maintain this downstream.
Yes, that's true.
So it could go in Mathlib itself next to archive, and then everyone is forced to maintain it. And if it turns out to be too much of a burden to maintain, then the experiment failed.
Mm-hmm. I don't know. If I asked Claude Code to give me some improved documentation from reading a file, how would that go? I'm too cheap to pay for any kind of credits for API usage.
Same as me. It's absolutely terrible. Never paid a dime to these tech companies. I'm supposed to
Oh,
be
but at the same
expert.
time now I have two different pro or plus, not pro, plus or whatever subscription levels when I only need maybe one or half of one. So
And then they pick up. Yeah. Right.
but when I
You don't
ask
need to do any
Claude
of
what
it.
it's good, you know, what Claude Code's good for, oh, it tells me it's good for improving your documentation.
So let's say you run Claude on, say, every file in Mathlib, and you update the doc strings to capture those files. We're now kind of in trouble if the files change, and actually now we discover these doc strings that don't match up.
Yeah, that's true.
something which is kind of related is the doc strings for fin.suck and fin.castsuck. They're both in core and they're not very good. I think if you understand how the terminology works, you can kind of decipher them, but it would be nice to have better doc strings for people using Mathlib for these core notions which come up in Mathlib.
Can you override doc strings nowadays?
Sorry?
Can you override doc strings?
Oh, I don't know.
No, I don't know either. Eric will know.
I think there might be some mechanism to append to doc strings, but for the type of thing where the doc string is
Ignore all that, read this instead.
I think you should just make a PR to call for those things.
Oh,
And
yeah,
I
yeah.
think docstring PRs for things like that are usually accepted. The only annoyance is that actually Mathlib users don't see them for another month.
Oh, right.
Yeah.
Well,
But
it's
that's all
been
reason to
years.
make it.
I have a feeling they had no doc strings at all, or almost useless ones, like a year ago, and maybe they've improved, but I think they still leave something to be desired. You've got these two maps from fin.n to fin.n+1, and it wasn't clear from the doc strings which is which.
I mean, certainly people think about, I mean, I was reading the reference manual, and the very first object in the reference manual, their verso springs into action, was like a definition without a doc string. And I moaned on the Lean 4 channel. It's like, what, like, but surely this very first definition should have a doc string. And then, like, it transpired that there was a PR that had just been made about the same time that, like, doc strings for every line in that file in core. So somebody out there is documenting core.
Yeah, I've seen some movement, but with a lot of these things, it just, someone just has to act on it, right? And just has to point it out, and then people are eager to make it happen.
I think you need to be careful here with, if you just take a random file in core and like document every single thing in the file, then you've now got maybe 50 or 100 things for the Lean FRO to disagree with and say, actually, this is technically incorrect. And so then your 99 other things get held up because you just threw this whole bunch at once. So I suspect it's more effective to like document 3 or 4 things at a time, send them over. And then if people disagree with them, then sure, your other ones at least got merged that were obvious.
The documentation of fin.suck does indeed suck. There's a really bad document. It's a successor with an increased bound.
All right, so if we can get an action item out of this, someone should go right now, make a PR, and improve the documentation.
PRing to core is scary, though.
Not for documentation. You don't even need it to build.
It's
It's scary for Lean changes
break
because you
it.
have to actually first compile all of Lean first, which is quite a commitment. But for a doc string, you can just assume that everything will be fine.
Why is Heather's repo broken? That needs a
Because,
spring clean.
well, from my investigation is that macOS started requiring a certain flag being set for linking back in February of 2024. And now for whatever reason, when we moved from the past version of macOS to the current version, that linking is not happening.
I thought the idea was I prove Fermat's last theorem, and then I can dump it there and retire and not bother updating it, and it will be a proof of Fermat's last theorem forever. And now I discover that actually no, like 1 year later, it won't compile anymore.
Does it not compile, or does it not compile when you run like update?
No, Heather's. You mean you bump? I
If
mean,
you
if you
just
bump
open Heather's
Mathlib, it will
repo
break
right
Heather's
now.
repo, and if you don't bump Mathlib, it now won't compile on a new
Okay.
Mac.
Yeah, Kim looked like they tried
And
maybe
that
pushing
kind
it
of
up to
terrified me.
one version.
This is because it uses Duper, which has some FFI dependencies. Is that the issue?
At least part of the problem is with Duper, yes.
For the bump or for the current issue?
not-
The
for
current
the
issue
current.
looked like it was Rob's autograder.
Yeah, that was at least one of the other issues.
Okay, because this way round, if they turn down GP center, they can finish GP.
That's kind. I found that kind of terrifying because I thought that could never happen, basically.
Oh, well, I mean, any software you build, you got to assume the world's going to shift out from underneath you, right?
I'm just very naive about. I've never built any software in my life. I have no idea.
Well, I mean, what do you compile it to that you don't think's gonna, like, you can compile it to assembly and then say, here's my proof for Maslow's theorem, right? If you want things not to move underneath you.
I have no idea what happens when you type lake build. All I know is that it either says yes or no. And I thought if it said yes, it would always say yes, and clearly I'm wrong. And that won't get quotes fixed. Is that not how life works?
I mean, I think whenever you build something, you got to bundle in the maintenance cost if you want it to live into the intermediate future.
Huh.
Not even talking about like the distant future.
I wonder how EPSEC will feel about that when I tell them that I now need monthly fee for the rest of my life.
Well, I mean, I think what Magma has this basically, right? And so they extract it with a license that you have to use, have to pay for. Although, Simon's paid for everyone on the
Right.
planet at some point.
No, everyone in the US.
Oh, okay, only the US.
Yeah.
I thought it was a little wider than that.
Might be in North America.
But at the same time, I mean, they have the funds to continue hiring people, keep doing work.
Well, they're
on this,
charging for
and
their
do interesting-
software.
I mean,
I need to put Fermat Serum behind a paywall. That's clearly the future.
no.
Or some fun. I need a funding stream.
You could do it like that one Wu-Tang Clan album, right? So it just gets given to one very rich person who can enjoy it themselves, and then no one else.
That's right. Yeah.
Yes.
Yeah. Unfortunately, the cat's out of the bag. Okay, maybe. Yeah. Well, we haven't got anywhere yet.
Well, I mean,
so maybe
but it's
I
not
should
the-
take
it's
it
not the point,
offline and
right?
then just develop it privately.
Yeah.
I've seen these great hacks where you can prove anything you like, and the print axioms doesn't show up. It looks fine. There's several ways of doing that.
So another item for spring cleaning is, is all our deprecated code deleted on time right now?
Yeah, because Jeremy Tan deletes
Oh.
it the day it's due for deletion.
What was our due date? Was it 6 months exactly?
Yeah, he just made a PR yesterday, deleting everything that was deprecated between the 1st and the 10th of October.
So every 10 days.
Yeah, I wish I could get him working on Fermat's last theorem, but he's currently helping Flores, so I guess we'll leave him alone. He came to London over the summer.
Oh yeah.
And never came to see me. He was even doing the museums right next to Imperial College, but just never. I don't know. I'd love to meet him. He's moving into. He's currently working for an AI company, but he's actually going to do a lean PhD.
Where's he going?
It's not in this fall. So I think Singapore. He's going to be doing lean on program verification. He mentioned that this was on the private Discord. He mentioned the name of his advisor, and it's someone that where I could just dig it out.
Good for him.
Yeah, because when I just imagined he was kind of a hobbyist. that was just going to like contribute for fun, but he's actually been sucked in. Ilya Sergey. He's going to be working with him about verifying large systems. Very much last there, that must be a large system. You can verify that. Yeah, Ilya Sergey, he was, do you remember that some people did small scale reflection for Lean? They
Oh
made sort of
yeah.
a new tactic language that was incomprehensible about a year
It was
ago.
very different, yes.
Yeah, they were just like,
But it
I
was
like
fun.
writing cock, and I like writing my code that looks like this, and now we can do this in Lean, and it's even better than cock because Lean's more flexible. And this deluge of questions of what the hell, this code is incomprehensible. And he was just like, oh no, that's just because you don't understand it because you're not used to writing in cock. Yeah, so he's working with that guy that did the
that's cool.
SSR Lean. So I'm sure Jeremy will have loads of fun.
Yeah, that was fun.
He's the world number one. Yeah.
So another item that's been sitting around, I think we even got some amount of documentation or instructions for this, was what are all the things we can write simprocs for and haven't done yet.
So
Was
again, we're working on a blog post
Okay.
about simprocs in general.
That's
Not a
right.
direct answer to your question, but is a tool to enable people to write the things that you want us to list.
Bye.
Does that exist now? I thought I saw it
There's
go
a
live
PR.
somewhere.
Is it live? Certainly it's reviewable. I don't know if it's on the public website.
I'd certainly reviewed about half of it, but I don't think it got merged yet. Yeah, this is all thanks to Heather. Heather came to Imperial and has been running a study group on metaprogramming at Yale, who's supposed to be doing a PhD in Sweden. She's constantly in London, and has been going to this metaprogramming study group. And then one day Heather couldn't make it, and so Yale gave a talk on metaprogramming and simprocs. But
So is this is this with QQ or is this core style?
well, you're not allowed. Yeah, probably with QQ. I didn't know you could not be with QQ.
You can, but then I tell you off in review.
Ah,
Unless Kim gets there first.
I see.
Given
So
the geographic constraints, you know when to start the PR if you want a favorable outcome, depending on which side of the line you fall on.
I see. So simprocs with QQ can't go in core.
But also a lot of simprocs are about things in Mathlib anyway, so they couldn't go in core.
Yeah, fair enough.
So if you're like writing a simproc about the divisors of an integer, then like there's no way that belongs in core anyway until divisors moves into core and
Mm-hmm.
division monoids move into core or whatever.
That'll be the day.
Speaking of things that will never move to core, I've tried to convince people that you should experiment with simprocs for concrete categories and simplification to try and strip away, oh, I need the HOM space and then I need this coercion to type, et cetera, et cetera. It's all wrapped up in there. And then simplest choking on it, although with Anne's work, it's gotten a lot better. Probably some mileage with that could be gained.
Yeah, Emily Real was moaning about concrete categories, so it'd be interesting to see if she had any problems that could be solved with simprocs.
I'm always very leery of the use of category theory across Mathlib.
Even in algebraic geometry?
I mean, it depends on whose algebraic geometry you're doing. I guess the modern style, right? But if I'm like just writing down equations all the time and pushing around those equations.
And it's hard to imagine category theories of any use to you. Yeah.
Yes.
I just reviewed a beautiful PR by Joël Rieu about X groups. He proved that X0 XY was HOM XY
Oh yeah.
in some
don't
arbitrary
know.
abelian category.
I would not know what we'd be doing without Joel.
No, he's completely awesome. And he has clearly got the hang of category theory. Although he knows, I know more tricks than him about how to get a natural from an integer, which is at least 0. He wrote sort of 5 lines to extract the natural. I was just like, there's lift. There's lift, Joel. Just lift it. But yeah, when it came to, he's got this derived. What's more, it seems like original work. He's doing all of this stuff. He's doing homological algebra in a universe setting, right? He's got all these X groups. He's got a category, and the objects live in U, and the morphisms live in V, and then the X groups live in W. And he's got these really kind of controlled things exactly when the X groups live in W. And it's not just all sort of just abstract wankery for its own sake. He's like got concrete examples in module doc strings, sort of saying, well, you look at the big et al site and it's big, and yet we do want cohomology groups to be small. I don't want the trivial group in type 1. I want the trivial group in type 0 if I take the cohomology of projective 2 space. So it's all motivated, but as far as I know, he's just worked the entire thing out. We desperately need a publication from this guy, but he's not got time to do any writing because he just spends all his time writing brilliant code. This is just ridiculous. He absolutely deserves a medal, Joel, what he's done. He's just written 10,000 lines of code and there's no publication. For him, the justification is just that, oh, look, we can have X groups. And we have them done correctly. It's absolutely awesome. I don't know what his line manager thinks, but I'd definitely give him a +1.
All right. Well, it looks like we're running up on the hour. One other thing for spring cleaning, I started scrolling back on that refactor representation theory, the thread there, and I got back to like 2022, and there was still a lot of it left. Well, that would have been fun to talk a little bit about, but
well, the answer is we don't know how to do it. Johan started a new idea today. Make him a class. Make representation a class. And then I asked him whether, as a consequence, every group would act trivially on every ring, which didn't sound good. I've yet to see what he's responded. But yeah.
We had this discussion a long time ago when we made the representation structure as it exists today, right? When you or someone was trying to add all these module instances or similar, maybe they were just null actions, and I was saying, no, these are great diamonds, and kind of the solution was, okay, just bundle them in the structure, and then there is no global impact of adding all these things. But I guess it's bad in other ways that we're discovering, having worked in it for a long time.
Yeah. Johan will sort it out. It's fine.
He's now paid to do it, right?
Is that right? Is that why he's doing it?
I mean, who knows? More from the perspective of the FRO pays him to do something unspecified with Mathlib. And maybe this falls in that category of unspecified beneficial things.
It certainly would be a beneficial thing.
Maybe they have an industrial sponsor that's specifically interested in representation theory.
Classification of finite simple groups uses it,
all right. So since it's been an hour, I want to respect people's time. It's been an interesting discussion. Thanks for showing up. Thanks for contributing. And I'll see you on Zulip, if not elsewhere. Take care.